Hello and welcome to NPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.61. Let me read the problem. If the position of the electron is measured within an accuracy of plus minus 0.002 nanometer, calculate the uncertainty in momentum of the electron. Suppose momentum of the electron is h by 4 pi into 0.05 nanometer. Is there any problem in defining this value? After reading the problem, I got to know that it is based on Heisenberg's uncertainty principle, and principle states it is not possible to determine the accurate position and accurate momentum of a moving particle simultaneously, and if an attempt is made to determine position and momentum of moving particle simultaneously, neither position will be accurate nor momentum will be accurate. There will be uncertainty in position and there will be uncertainty in momentum, and the product of uncertainty in position and uncertainty in momentum will be always constant, and value of this constant will be either equal to h by 4 pi or greater than h by 4 pi. And for practical purposes, value of constant is taken equals minimum value, which is defined h by 4 pi. Maximum value is not defined, can take any maximum value. And coming to problem, I will use this equation that as per Heisenberg uncertainty principle, product of uncertainty in position and uncertainty in momentum is constant, and value of this constant is either equal to h by 4 pi or greater than h by 4 pi. And for problem solving, value of constant is taken is equal to its minimum value, which is defined, that is h by 4 pi. Now looking into the problem, I know uncertainty in position is given equal to 0.002 nanometer. I will first convert it into meters. It will be equal to 2 into 10 to the power minus 12 meter. Now I have to calculate uncertainty in momentum. Uncertainty in momentum I need to calculate. I will use this applied form of Heisenberg uncertainty principle equation. Del uncertainty in momentum will be equal to h divided by 4 pi into uncertainty in position, which is 2 into 10 to the power minus 12. Let me write here first at uncertainty in position delta x. Now I will substitute values. Uncertainty in momentum will be equal to 6.626 into 10 to the power minus 34 divided by 4 into 3.14 into uncertainty in position is given 2 into 10 to the power minus 12, and I have calculated value of uncertainty in momentum, and value comes equal to delta p. Uncertainty in momentum comes equal to 2.63 into 10 to the power minus 23. Now moving to part second of this problem. In part first, I had to calculate uncertainty in momentum when uncertainty in position was given equal to this. I did simple substitution of given parameter, given value of uncertainty in position and known values of constants h and 4 pi. Here I got value of uncertainty in momentum is this. 2.63 into 10 to the power minus 23, and unit will be its kilogram meter per second, because momentum is product of mass and velocity. SI, in SI system, unit of mass is kilogram and velocity is meter per second. Now moving to part second. Suppose the momentum of electron is h by 4 pi into 0.05 nanometer. Is there any problem in defining this value? What is uncertainty in momentum? Uncertainty in momentum is difference between actual momentum and observed momentum. Now actual momentum is equal to observed momentum plus uncertainty in momentum, and from this equation it is expected, on basis of this equation it is expected that uncertainty in momentum is less than actual value of momentum. This is expected. If given value of momentum is greater than uncertainty in momentum, which is equal to this value, if this given value of momentum is greater than calculated value of uncertainty in momentum, then value is meaningful. Or else, if given value of momentum is less than uncertainty in momentum and the calculated value of uncertainty in momentum is this, as calculated in part first, then value of given momentum is meaningless. It has no significance. Let us compare given value of momentum with uncertainty in momentum. Given value of momentum P is equal to h divided by 4 pi into 0.05 nanometer. For us this is P actual. For us this is actual momentum, and actual momentum is equal to h divided by 4 pi into 0.05 nanometer. Now uncertainty in momentum value, I will compare these two values. I will compare momentum, given value of momentum PA, which is equal to h divided by 4 into pi into 0.05 nanometer, with uncertainty in momentum, and calculated value of uncertainty in momentum is this, and I got this value from this equation, h divided by 4 pi into uncertainty in position was given 0.002 nanometer. Now I will compare given value of momentum with calculated value of uncertainty in momentum, and I expect if given value of momentum is greater than calculated value of uncertainty in momentum, then given value of momentum is rational or meaningful or it has significance. Otherwise it is not defined, it is meaningless. Comparing, first I will compare numerator of both the sides. Numerator is h here, numerator is h here. Now coming to denominator, in the denominator both have one thing common, that is 4 pi. But this value, uncertainty in position, is different. Here it is 0.05, here it is 0.002. And wherein denominator, wherein denominator is less, value of delta p will be greater. Here, because of this value 0.002 related to 0.05 is less, so denominator here is less. Uncertainty in momentum, calculated value of uncertainty in momentum is greater than, here denominator is greater, value of denominator is greater, 0.05 is greater related to 0.002, so given value of momentum is less. So after comparing, what is observation? After comparing observation is that PA, or else I will say uncertainty, calculated value of uncertainty in momentum is greater than given value of momentum, which contradicts this statement, which contradicts the expected statement. So given value of momentum, so P is equal to h by 4 pi into 0.002 nanometer is meaningless. This value is meaningless. Let me recall the problem. Problem had two parts. In part first, uncertainty in position was given. We had to calculate uncertainty in momentum. I used, for practical purpose, as I said that product of uncertainties is constant and value of constant is taken equal to minimum value, which is its defined value, equal to h by 4 pi. Simple substitution of given uncertainty in position and known values of constants in the equation gave me, by simple substitution of known value of uncertainty in position and given value of uncertainty in position and known values of constants, I was able to calculate uncertainty in momentum, which is equal to 2.63 into 10 to the power minus 23. Now I had to answer second part, where I had to say that whether given value of momentum h by 4 pi 0.002 nanometer has meaning, is it defined or is it not defined, is it meaningful or meaningless. For that I said it is expected that uncertainty in momentum, value of uncertainty in momentum should come less than actual momentum. But here, after comparison of uncertainty in momentum with a given value of momentum, I find that uncertainty in momentum is greater than given value of momentum, which contradicts the expected statement. On basis of this, I said that the given value of momentum of electron in the question is not meaningful, it is meaningless. And additional information is that this is constant, h by 4 pi is constant. It means if uncertainty in momentum is greater, that time uncertainty in position will be less, or else if uncertainty in momentum is less, that time uncertainty in momentum will be greater. And instead of P, I can write mass and velocity, and mass I will take here, it will become delta x cross delta v is equal to h by 4 pi m, and using that equation I can come to know the significance of this Heisenberg uncertainty principle. And if mass is greater, product of uncertainty will be less, not significant in case of large sized particles. But if mass is less, for example, for an electron moving in an atom, product of uncertainty will be greater, uncertainty in position will be greater, uncertainty in momentum will be greater. So for an electron moving in an orbit, position is uncertain and momentum or velocity is uncertain. This contradicts Bohr's model, in which Bohr said that trajectory or path of electron is fixed. But path of electron, from this concept we get to know path or trajectory of moving particle is determined by its position and velocity. And if position is not certain, if momentum or velocity is not certain, then path cannot be fixed, position cannot be fixed, momentum or velocity cannot be fixed. So in wave mechanical model of atom, instead of fixed path, fixed position and fixed velocity, we talk of probable trajectory or probable path of electron, probable position of electron and probable momentum or velocity of the electron. This is consequence of Heisenberg uncertainty principle on Bohr's model of atom, that it contradicts the word fixed used by Bohr in his model, and word fixed is replaced by probable word in the new model of atom, that is quantum mechanical model of atom or wave mechanical model of atom, which is primarily based on dual matter wave, dual character of electron and Heisenberg uncertainty principle. Class 11 students, this is the problem I have got for you today. See you day after tomorrow with one new chemistry problem. Till then, take good care of yourself. Allah Hafiz. And tomorrow is turn of class 12 students.